Let's move ahead, following to the discussions on the readiness. Join us to the In SpaceX 3.0 for the further discussions. Can we have the video of the same, please? So the war game is till 6 p.m. today in the evening. And kindly register yourself to join the exercise. The scan code is at the registration desk itself. And we move ahead. The next on the agenda is C2C Advanced System, the tech brief, futuristic C4ISR systems, an architectural framework-driven approach. For the same, I call upon Mr. Krishna Chandra, Chief Mentor, C2C Advanced System, along with Commander K. Ramesh, Chief Technology Officer, C2C Advanced Systems.
Good afternoon. My name is Krishna. As I look around myself here, I have people who have dedicated their life for the safety and security of India, and I salute them. I'm not an expert on military warfare, but I come from an area of technology that I believe is essential to take the country forward from a conceptual standpoint. We are in an era of where the artifacts that we have today, some of it is current, some of it is old, and some of it is going to emerge in the future. And I think they are transforming at a rate that we can't even imagine. And the quantum computing and advanced chips is going to make a huge difference as we move forward. With the significant advancement in this hardware technology, the one area that seems to be somewhat lagging is using software technologies to integrate all of the artifacts that we have, whether it's legacy or today's or in the future, which we believe is essential to be able to work in an atmosphere in warfare where asymmetry is the underlying theme. So our strategy in what we are doing is to build what we call as a Magi C4ISR platform. And the platform seeks to integrate seekers, sensors, communication data, artificial intelligence, machine learning, and cybersecurity into a single nimble, flexible platform that can be applied across various domains so that we are in a position to work in an asymmetric way as is required. The old method of a whole bunch of pieces of puzzle coming together and hoping that we will use one or the other doesn't exist anymore. What exists today is ability to be nimble, very fast, and to be able to put it together. So this is our strategy. And what we did do is about 5 years ago, we created the first version of the platform. Before we could sell into India, we sold it in Malaysia for 2 frigates, which had British Aerospace legacy systems. We completely transformed it into a command and control combat management system for those 2 frigates. And we won that contract against Lockheed Martin, British Aerospace, and Saab. Have we been successful in India? Absolutely not. The recognition that an Indian company can do both on the system architecture and the tactical software has not been accepted in India. So it takes very long time for us to enter this market. The second aspect that I want to mention here is software always seems to take a back seat in acquisition of equipment. I think everybody wants to buy a piece of equipment, but they don't think about the software that goes into it, how that software is going to integrate with the rest of it. That's what C4ISR Magi platform, as we call it. It's still under development. Several versions are out. Hopefully over the next few years, it will see the same level of standard as any standard anywhere in the world. That's our goal. I put up this slide only because to say that the warfare itself is asymmetric, and as you all know that water flows the way it wants to flow. Similarly, I think the fighting also has to flow the way it needs to happen. And with this day of very high levels of information available, if we don't put them together, it won't work. So with those thoughts, I'm going to let my colleague, Commander Ramesh, I can talk about the challenges, but I think it's important that he talk about what we have done. Thank you.
Check. Thank you, Mr. Chandra. Can we have the presentation? Yeah. Okay. Good afternoon to all of you. We have been talking a lot about multi-domain operations. We had a talk about the whats and the whys of the multi-domain operations. What I would like to cover is the how of the multi-domain operations. How are we going to develop systems which are capable of multi-domain operations? So basically, I would like to cover, we'll start with an introduction to C4ISR and what has been the inspiration for this architectural framework. Then we'll talk about the elements of this architectural framework. What are the building blocks of this particular framework? And something that we call as a C4ISR data ontology. And we will talk about what we have implemented using this particular framework. The introduction to C4ISR, I think we have an audience full of people who are deeply conversant with C4ISR. So I really need not go into the details of it. Fundamentally, it's command and control, communications, computers, intelligence, surveillance, and reconnaissance. So when we talk about command and control, we are basically talking about situational awareness, battlefield management, tasking, and coordination, and resource allocation. In terms of communication, we are talking about data transmission, network management, net-centric communications. In computers, we basically talk about data processing, data storage, software applications, and cyber security. And in intelligence, we talk about the collation, analysis, and dissemination of intelligence. And in surveillance and reconnaissance, we are talking about sensor integration, target detection, target tracking, and geospatial intelligence. It is important for us to understand the various components so that when we talk about the building blocks, we will come to them. Next is to understand what are the key technologies. As I said, we are talking about the how part of C4ISR. So we need to know how we are going to implement the C4ISR. First, key technology that is required is a robust interface to diverse origin weapons, sensors, autonomous systems, and what is now being called as IOBT, that is the Internet of Battlefield Things, which is akin to the IIoT that the industry talks about. One of the most important components is the multi-platform, multi-sensor data fusion, which is a very, very core technology as far as C4ISR is concerned. Secure networking through tactical and strategic data links. I think we had a lot of talk about that during today's lecture. Integrated with modern and intuitive user interface. The new generation that comes to us are used to the pinch and swipe generation. So it is imperative that the UI will need to be catering to that particular generation. The next is the traditional rule-based algorithms. We heard a lot of talk about artificial intelligence, but maybe a sort of disagreement in the sense that we really cannot run away from rule-based algorithms. And rule-based algorithms for common operational picture, threat evaluation, resource allocation, and centralized and autonomous control of sensors and weapons are a must. Of course, AI/ML is also a key technology, and we are looking at that for object detection and recommended best course of action, resource optimization, and simulation of wargaming. So C4ISR implementation is fundamentally as a sensor shooter grid. It's forming a seamless chain from detection to engagement. It's a network of sensors to detect targets, pass the information through the information grid, quick and precise targeting by shooters. This is just a block diagram. I think I will just skip this. C4ISR implementation also needs to be done at various operational levels. For example, we have the strategic level, operational level, and the tactical level. Strategic level catering for high level and long-term planning. Operational level catering for mid-level planning, coordinate large-scale military operations. And the tactical level is immediate actions and maneuvers and individual engagements. This layered architecture is extremely important for us while we look at the implementation part. So there is a control interface from the higher to the lower, and there is a view interface from the lower to the higher. The importance of this implementation pattern will emerge as we keep moving forward. This is just giving you a bird's eye view of the three levels. We have a strategic network, a tactical network, and at the lowest level, we have something called as a wireless network. And we have integration across all these three layers that we're talking about. Across the various operation levels, you have the strategic, operational, and the tactical. We have various applications that need to be developed, which is, for example, you talk about a situational awareness. A situational awareness needs to have a different flavor for tactical, operational, and strategic layers. Similarly, we are talking about multi-platform, multi-sensor data fusion, threat evaluation, data analytics, and the other components. What is the need for a framework? Presently, what we do is that we build individual systems with specific capabilities, and then we build interoperability where systems where they are required, and no common framework for design and development. This is a fundamental problem that we have while we look at designing systems for MDO. This leads to interoperability issues. There is no common data language. Interoperability is not designed in. So often it's an afterthought that comes in. And lack of system of systems approach, which is fundamentally a systems engineering approach. Okay. We are also talking about scalability issues and extensibility issues. What are the elements of the architectural framework? What we have derived is fundamentally a process framework, a development framework, and a systems engineering framework. The process framework is consisting of basically well-defined processes within the organization which is developing it. And all the processes are defined in terms of policies, procedures, templates, and checklists. And when we talk about systems engineering approach, we are talking about a sort of INCOSE standards which we have imbibed within the system. And we are basically talking about 8 well-defined stages, which all of us are already aware. This development framework is what I would like to talk about in more detailed, little more details. The framework is consisting of 2 components, basically the data ontology and the application building blocks. You can see here that the data ontology is derived from a design from a top-down approach, and the building blocks is a development from the bottom-up approach. So the approach is fundamentally a mixture of both the top-down as well as bottom-up approach. What are the building blocks? We basically define some building blocks. You can see here we are basically talking about an interface block, a computation block, a GUI block, and a communication block. Each of these blocks are given specific tasks to be conducted, which are integrated. For example, a data interface box, we are talking about all sorts of data interfaces, multivariate inputs, standard outputs, data translations, data hook to each communication block. What you're seeing as an arrow there is a data hook actually, and the data output is as per a C4ISR data ontology. Various types of data interfaces are catered for. Various protocols and interfaces are catered for as part of this particular system. The computation blocks is encapsulating all the computation elements as we just talked about earlier: MPMS, DF, threat evaluation, resource allocation, mission planning, logistics planning, tactical data link. All these things are the basic computation blocks that are built. And blocks, as I said earlier, was defined at appropriate levels, whether it is a strategic, operational, or a tactical layer. And all the interfaces are as per the C4ISR data ontology. We have a graphic user interface which talks about all standard interfaces: screens, touch screens, joysticks, trackpads, and all the likes. And we are talking about very modern widgets for user interface. We have internal communication blocks. This is catering for different types of communication between the systems. Internal communication blocks caters for within a system. Inter-level communication blocks caters for within levels. And a system communication blocks talks about system to a system to a system of systems. So using these building blocks, what we have done is we have built a system block, which you can see here is consisting of data interface, communication, computation, and GUI blocks. All of them are built as per an ontology. A system of system block, which is basically 2 systems which are intercommunicating between each other using a sort of a system level communication block, which you can see here. And a multi-level system block, which talks about multi-level different systems talking to each other using a different type of a communication block. Data ontology. There are various definitions of data ontology. Fundamentally, it's a common data language using the same data dictionary. And data ontology, as you're all aware, is very, very domain specific. That is where the importance of domain specific experts come into this defining of this. Why it is required? We have all of us have heard about the Tower of Babel legend, where it says that the human race at one time was all speaking the same language, and they wanted to build a tower, and the gods were rather feeling threatened. And the only thing that they did is that they just ensured that the humans spoke different languages. Now, what we are talking about is doing exactly the reverse. We are trying to say that we want to integrate systems. The only thing that we are going to do is that ensure that all these systems talk the same language. That is what the data ontology actually does. So it's a common vocabulary that we are talking about. Okay, so I will skip this features. These are all the features of data ontology. I will talk about what we have done. We have implemented what we call as a Yodha family of systems. Baseline 1, 2, and 3. One catering for the Navy, another for the Army, and the other one for the Air Force. And we have a baseline 1, which is catering for the naval specific capabilities. You can see here shared situation awareness, warfare support, command and control, data link, and fleet management. And this is an architecture of the system that we have developed and deployed on one of the naval warships. We are talking about the baseline 2, which catering for the Army system. So here we are talking about a common operational picture, GIS overlay, Blue Force tracking. We're talking about air defense systems. For want of time, I think I will skip these things. These are all the components that has already been developed. So what I will just cover the overall capability of this system. Fundamentally, the design and development framework consists of a data ontology and C4ISR building blocks. Data ontology, we do a top-down design, and building blocks, we do a bottom-up analysis, and we develop systems, like you can see here, the 5 support systems, DCCS and other that, system of systems, and multi-level systems, and multi-domain operation systems. So this is the capability of this particular framework that we have, that we can build from the smallest to the largest system. So I've completed. If there are any questions. Thank you.